I'm an engineer, so I'm going to come at this from an engineering perspective. I've worked in the energy sector for my whole career. And I want to talk about risk a little bit. I'll talk about D&V a bit in case people don't know who we are. But why are we talking about risk with AI? And it's really we're talking about safety critical systems here and critical national infrastructure when we talk about the energy system. The lights have to stay on. And engineers tend to be somewhat risk averse because of the potential consequences. This doesn't mean risk avoidance, but it does mean risk management, and which is fundamental to engineering, really. No system is risk-free, but if we manage risk, we can unlock that technological progress. Now, the energy sector, as we've been discussing, is undergoing this major transition. The energy transition moving from large-scale dispatchable power into renewables. And that plus this digitalization is increasing complexity in the system and therefore introducing uncertainty. Now, AI as a toolkit offers a way of managing that uncertainty in energy system while also introducing its own challenges. But very quickly, just to give our credentials. If you don't know D&V, we are a global independent assurance risk management firm. We're one of the largest companies in the energy sector you've not heard of. We cover many aspects of the energy sector, plus shipping and maritime, and software and cybersecurity and so on. So we're the people who do the independent verification of physical and digital systems and provide certification thereof. So we operate globally. We're doing this for 160 years, though I will emphasize that I personally have not been doing this for 160 years. So we really focus on practical risk management in high-risk sectors. So we do know what we're talking about. Personally, my own careers followed the energy transition trajectory as well. I started with a PhD in numerical modeling. We didn't call anything AI back then, or even machine learning. I've then worked in the power sector looking at CCS. Then I've done risk management for offshore oil and gas. And now more recently, moving into digital and working more in the renewable space as well. So we are seeing, these are two historic transitions. In terms of human history, these are two historic transitions, right? The energy system or the power grid is the biggest machine humanity has built. And we are now having to rebuild that machine at rapid speed. And in the process, we're introducing all this uncertainty and complexity. Now, AI enables us to manage that uncertainty and complexity, and in a way that humans no longer can. We're no longer operating a power grid like a central dispatch office. We've got much more distributed system. We've got changes to the demand side in terms of even just domestic use. And we're seeing the supply side changing as well, because we're now relying on weather, solar, wind, etc., which are much less predictable than, say, a supply of coal or oil and gas. So we're seeing demand changes and supply changes. And balancing this out, as Harry was saying, is a job. Really, it's a job for a digital system like an AI. So we can use AI. Really, it's to support the operators, help them with autonomous dispatch, and so on. So fire on through. So we're going to move from, say, manual operation control, which the system was designed to do back in the 1960s, And now we're moving to a more autonomous regime, potentially. And we're already seeing aspects of this in operation in various places. So we're already seeing autonomous control of valves and other things in, say, the gas sector. This move, again, because it's so complex, we need to be able to manage the risks of that complexity. And AI itself, while a solution to that complexity in energy, introduces a whole bunch of new complexities that we maybe don't see to start with. We're operating the system a different way, and we're operating it with the models that we don't know how they're coming up with their decisions. So how do we manage this risk? Well, we apply the same techniques that we've always done to the system. So AI risks are real and need to be managed. I'm going to pull an example here from the automotive sector. Fortunately, we don't have any great examples of AI failure in the energy sector at the moment, but that's probably due to the fact it has a low penetration into the system so far. But what we see is these autonomous systems, where they are in use, introduce both systemic risks, so failures from interaction between the components, not just the components themselves, but also these new emergent risks where we're getting unexpected behavior because the system is more complex. There's areas of active research, especially in the UK. University of York, for example, have a Centre for Assuring Autonomy, which is looking specifically into these aspects in safety critical systems. The challenge is that these risks can be then magnified by market pressure, by governance failure, and say a regulatory framework which maybe isn't geared to this new reality. So just on one specific example, in 2018, I think, this was the first known fatality involving an autonomous vehicle. And it's an interesting case study for sure. What it illustrated, rather than just apportioning blame to certain individuals, is it showed, just like most critical failures, it's a systemic series of failures, not just one part that caused this accident and an unfortunate fatality. All the way through from a lack of expertise at the regulator, this rapid pace of technology, the lack of controls, control systems or backup systems, and also operator failure. So this emergent behavior is already causing challenges in other sectors. And as we see this coming into the energy sector, we're going to see similar faults eventually. And I suppose the important thing is that we can learn the lessons of history. We have built up our health and safety legislation over decades, learning from accidents across multiple sectors. We're at this point now with AI where we haven't quite introduced it enough that we're seeing these problems. So we've got this opportunity now to really ensure it's trustworthy from the start. How do we do that? Well, Harry's touched on a few of these things already, actually. The data quality, absolutely essential. You know, we can apply assurance processes that we've been applying for decades. As I say, we've got a 160-year history of doing this. And we can bring that experience into the digital realm. And we already cover most of these topics. But as Harry says, data quality, absolutely essential. That underpins all of the modeling. Data sharing, super important as well. Sensor data, super important. We're now seeing these systems being censored up. But because we're talking about power grids and remote sites, these sensors are also in remote sites, so they themselves fail, or their connectivity fails. So we have to be able to to ensure we're getting quality data from the sites. And of course, the algorithms and the models all have to be verified and make sure that they're doing what they say they do. And if we can capture all of these elements, we will be able to assure these AI-enabled systems. Now, so it's just my final slide. I can say that this isn't theoretical stuff. We've published, DNV's published a suite of recommended practices around assuring digital systems. This is about 6 years ago we published these, and we're not the only organization to do so. There are ISO standards available as well. So we already have the toolkit.